Hello and welcome to the next video dealing with inequalities and with particular reference to quadratic inequalities, which will require a bit more work compared to linear inequalities. So let's get stuck in. Now a quadratic inequality looks something like this, okay? And there's a really simple way of solving it, but you have to be very consistent with the method and you have to make sure that you hit all the steps to get all the marks. So the simplest way to solve a quadratic inequality, first of all, replace the inequality sign with an equals, solve it to find the roots, draw a graph, and there is one final thing that I want to mention here: find the inequality. So it looks like a typo. Okay, so let's get into this then. So solve the inequality here, but before we get into doing the maths, let's just understand what this is saying. This is saying, when is this quadratic graph x squared plus 2x minus 3, for what values of x is it greater than 0? Is it positive? Okay, so you make sure when you're reading quadratic inequalities you actually understand what it's trying to say. When is this quadratic graph, for what values of x, because inequalities are values or regions of x, is that positive? So let's go through the steps here. Let's replace the signs. Okay. Let's then solve the quadratic equation to find the roots. Okay. And now I can do that by factorising, which shouldn't be too difficult. Okay, so I've solved it to find the roots. I've done my second step. I'm going to now draw the graph of this quadratic. Quick sketch. Sorry, -3 here, and -3 there. Okay, it cuts through at -3 on the y-intercept because that information comes from here. And if I just do a quick sketch of the graph, okay, it's going to look something like that. Not the best sketch, but nonetheless, just a quick sketch just to see what's going on. Okay, right. And once I've done my sketch, I need to find the inequality. And remember what you sort of started off with. When is this quadratic graph positive? When is it greater than 0? So what you should do, put your pen and sort of think to yourself, start from here and think, okay, at this point, is the graph or is the value here positive? Value of the graph, it is, it's above the x-axis. It's still positive, still positive, still positive, still positive. But as soon as it gets below the x-axis, the graph values become negative. The y values, yeah? Negative, 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 positive, 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 positive. So there are clearly two regions for which this inequality is greater than 0. The two regions are everything greater than 1 and everything less than -3. Because if I extend the graph either direction, it will carry on going infinitely, okay, and it will carry on its positive nature. So in terms of my final answer, the solution to this quadratic inequality is x is less than -3 or x is greater than 1. Okay, and they're two separate inequalities, which you could write as in terms of set notation, and that would be as such: -3 or x greater than 1. Okay, so that's the first question. Let's just repeat the steps again. You read the question and think, when is the quadratic greater than 0, or when is it positive? you change the inequality to an equals, you factorize and solve, and then that will help you draw the graph, and that will help you to pinpoint the regions for where that graph is positive. Right, next question. It's a bit more difficult. Solve this inequality here. 3 plus 5x minus 2x squared greater than or equal to x plus 3. Now, there are two ways of doing this. You can either do this by sketching both graphs on an xy axis and seeing where this graph is greater than that graph. Another way, which would probably be more preferable, is to make one side equal to 0. And it doesn't really matter which side I can make equal to 0 as long as I get the right answer at the end. So what I'm going to do is I'm going to everything that's on the left hand side, because I want a positive quadratic which is easier to factorise, I'm going to chuck everything from here onto that side. Okay, so when I do that, the left hand side is obviously 0, there's nothing on the left hand side. I've got my 2x squared and it's positive, which is good. I've got minus 3 because I took the 3 over as minus. I've got minus 5x because I took the 5x over. I've still got the x plus 3, which is already here. Okay, and if I tidy this up a little bit, the minus 3 and the plus 3, and then you've got minus 5x plus x, which is minus 4x. But all of that, this is less than or equal to 0, so I can just rewrite that as that. Okay, because everything on the right hand side was less than or equal to 0, I'm just going to rewrite it in a form which is easier. Okay, now what I'm going to do is I'm going to factorise out the 2x. Okay, I'm then going to replace the equal sign, the inequality with an equal sign. Okay, I'm going to solve, so I get x equals 2 or x equals 0. Okay, and when I sketch the graph, it's going to look something like this: 0 and 2, and it's a positive quadratic, which I've sort of written down. It's going to look like that. And the question is saying, well, I've changed the question from something that looks quite difficult to this. This is now the question: solve this inequality. Yeah, I've just changed the question to something which I can handle. Okay, so I need to solve this inequality. When is this graph less than or equal to 0? I.e., in other words, when is the graph negative? So again, if you put your pen on the graph is positive. It has positive values here in terms of the y values. Positive, positive, positive. Underneath the x-axis it becomes negative, and positive, positive, positive. So the region in which it's negative is between 0 and 2. Okay, everything between 0 and 2, that graph has negative y values, is less than or equal to 0. Okay, so as a final answer, you would say that. Okay, or if you want to write it in set notation, like that. Okay, so just be aware of these differences. Okay, right, the final question comes down to here. Find the set of values for x for which that is greater than x squared and that is greater than 2. So I need to solve these separately. Again, I'm just going to take this left hand side and take it over there. So I get x squared minus 4x minus 12. Okay, which I'm just going to rewrite. It's less than 0, just going to rewrite it like that. Factorise it. Make the inequality equal to 0. When you factorise it, two numbers that make minus 12 will give you minus 4. Okay, so you get x equals 6 and minus 2, and this one here, solve that, x is greater than 1. Okay, right, so that one was very easy to solve. We just have to get the inequality for that, and then we can come up with the final answer. So if I do a quick sketch, got minus 2, got 6, and it cuts at minus 12. Okay, minus 12. The y-intercept's not too important when it comes to the inequalities, but still. Right, so when is the graph less than 0? And as we've seen in the previous example, any quadratic graph is less than 0 for the section that's below the x-axis, so between minus 2 and 6. Okay, and we'd write it like this. Now we've got two inequalities here, and we need to make sure that we have a set of values for x which solves both of them. So what I'm going to do is I'm just going to draw a line, a number line. Okay, I've got 0 in the middle, I've got 1, I've got minus 1, I've got minus 2, and let's say I've got 6 all the way here. I'm going to draw two different lines on this number line. The first one is everything greater than 1, but not equal to 1. Okay, I'm sure you're familiar with this symbol, the white dot signifying not including. Then we've got everything between minus 2 and 6, but not inclusive. Okay, now we've got to find a range of values which satisfy both of these inequalities, and the only one that could work is the one that satisfies that sort of match up above each other. Okay, so if you look at the lines together, okay, which one is directly above each other? Well, if I pick between minus 2 and 1, if I say my answer is between minus 2 and 1, then that won't satisfy this inequality here, because it has to be greater than 1. But if I say my answer is between 1 and 6, then not only will that satisfy this inequality here, but it will satisfy that inequality there. Okay, so that is my answer, and you can write that in set notation. Okay, so let's just do a quick recap on quadratic inequalities. First of all, you replace the inequality with an equal sign, factorize and solve, do a quick sketch just to see where the regions are, where the graph is greater than 0 or positive, or where it's less than 0 where it's negative. You come up with the answer. It could be two separate inequalities, and that's normally the case when you've got greater than 0, especially with a positive quadratic, or one entire inequality, and that's normally the case when it's a positive quadratic and you're looking at less than or equal to 0. It's really important that you can practice these sorts of questions. Okay, at the bottom of the page you've got these practice questions here. I would recommend that you have a go at them. If you feel fairly confident, there's a stretch and challenge there. That's the end of the video.